Hello, welcome back to this beautiful channel. My name is Nawaila. In this period, I'll be taking your chemistry and we're going to take it literally step by step. I want to make sure that every student is carried along. We'll make sure to do justice to every topic we teach here, and we pray that you stay with us. This is going to be an exciting journey. Please kindly stay with us. I got the in the bag, or stock is attached. Alright, let's begin with the atom. Now the atom is defined as the smallest part of an element which can take part in a chemical reaction. So the atom is the smallest particle of an element which can take part in a chemical reaction. Now if you look at the board here, I've written an atom and an element simultaneously. Now the reason I'm putting this together is because we're told that the atom is the smallest part of an element. It means the atom is the element but just a small part of it. So I'll be talking about them simultaneously. So let us begin with the structure of the atom, how the atom actually looks like. Now the atom, first of all, is it is the smallest of anything that is existing on earth. There is nothing that is as small as the atom. No matter how small you think a substance is, think about the smallest part of the small you're talking about. So now the atom is extremely small. Even the electron microscope could not view it. Now, but we have gathered an experiment and we found out that the structure of the atom looks like this. Tons of scientists have carried out an experiment and it was agreed to look like this. Now, the atom has two major parts. Now, the first part of the atom is the inner side, which is called the nucleus, and the outer part, which is called the shell. Now, we have two major parts. We have the nucleus inside and the shell, which is the outside. Just think about an egg that is boiled. Now the yolk inside is serving as the nucleus, while the whiter part is serving as the shell. Now there are contents that are found in these two parts. Now inside the nucleus, we have two things existing there. In the nucleus, we have this one I labeled P here, is called the proton, and the one labeled N here is called the neutron. Now the proton and the neutron are found inside the nucleus of the atom, while on the shell we have the electron. Now so the electron is the only particle found in the shell. Now these three particles together form the atom. Don't get this mistaken. We don't have 1, 2, 3, 4, 5 particles of the atom. We have just 3. We have two places where we can find these 3 particles. We have the nucleus and the shell. In the nucleus, we have protons and neutrons. On the shell, we have electrons. Now these 3 subatomic particles, let me call it proton, neutron, electron. The 3 of them are called subatomic particles. Subatomic particles. Now these are particles that come together to form the atom. Now these particles carry charges with them. Now if you look at the diagram, I have put I made the P, I drew plus here, and on the N it is times, and on the E it is negative. Now this is telling us that the electron is negatively charged, the proton is positively charged, and the neutron has no charge. So the proton and the electron, positive, negative, and the neutron is electrically neutral. So my short form here is P positive for proton, N neutral for neutron, and then electron, which is the last, becomes negative. So as you can see here, the proton is positively charged, the electron is negatively charged, and the neutron has no charge, so we call it neutral. Now so the atom has two charges and a substance which has no charge. So in the nucleus we have the proton, which is positive, the neutron, which is neutral, and on the shell we have the electron, which is negative. All together we call them the subatomic particles. Now so many questions will be going on in the minds of students. Is the atom charged? And the atom has a positive charge, it has a negative charge, and it has a substance that is neutral. So is the atom charged? Now there are conditions that are there, but for now the atom is actually electrically neutral because it has proton, which is positive, and it has electron, which is negative. So in a neutral atom, the number of protons actually balances out the number of electrons. Now a neutral atom has number of protons equaling number of electrons. So the number of protons always balances the number of electrons for every neutral atom. Now when there is imbalances, maybe something happens to the atom, that is when the charges comes up. But we're going to explain this more when we start discussing about ions. So for now, the atom is actually electrically neutral because the number of protons in the nucleus always balances the number of electrons on the shell. So how do these atoms exist? Did they actually exist like I have drawn above? Yes. But the problem is there are different forms in which these atoms tend to present themselves. Now let's assume you and I are carrying out a research in search of how the structure of these atoms actually looks like, and the result we're going to find is that we're going to have different versions of this atom. Now the atom actually is existing in versions, so it is these versions that I want to discuss with you right now. Now in our search, this is what we're going to find. Now we're going to find out that some atoms exist like this. They have one proton and one electron. Permit me to take out the neutron so that I better explain this to you. We're going to find out that some other atoms have 2 protons and 2 electrons. We're going to find other atoms having 3 protons and 3 electrons. We keep on going, and it is found out that the last atom actually had 118 protons and 118 electrons. Remember I said that the number of protons must balance the number of electrons. So if an atom has 1 proton, it automatically has 1 electron. If it has 100 protons, it automatically has 100 electrons. So these are different versions in which this atom exists, and what gives them these versions is the variation in the number of protons to the number of electrons. Quote me right, even the number of neutrons keep changing. I omitted it because I want to bring out an explanation with regards to that. So now we have this atom. This is an atom. Let us call it atom A1, atom A2, atom A3, and so on and so forth. Now this, what do we call this atom? What do we call the second atom? And what do we call the third atom? They are all atoms, but they're changing. I get it now. Now the reason, even in the family, you find out that the first child has a name, the second child has a name, but they are all children. Are you getting it now? So these are all atoms, so we decided to name them. Now I want to explain to you why I actually tag the name atoms and elements to teach them simultaneously, because they actually meant the same, but there is just a little variation. So now the A1, the atom that has 1 proton, 1 electron, has a name, and we call it hydrogen. The atom that has 2 protons, 2 electrons has a name, we call it helium. The atom that has 3 protons, 3 electrons has a name, we call it lithium. So if you see calcium, calcium is actually number 20 in the periodic table. It is telling us that, okay, calcium is number 20 because calcium has 20 protons, 20 electrons. The same which applies to hydrogen. Hydrogen has 1 proton, 1 electron. Because it has 1 proton, we call it hydrogen. So wherever we find any atom that has just 1 proton, 1 electron, we call that atom hydrogen. When we find the one that has 3 protons, 3 electrons, we call it lithium. Now if you go to the periodic table, you find out that the periodic table is a table that consists of various elements. We have a total of 118 elements in the periodic table. This is telling us that the element number 118 has 118 protons and has 118 electrons. So now what is the atom? as I've said earlier, the atom is the smallest part of an element which can take part in a chemical reaction. If you analyze the definition very well, you find out that they didn't say the atom is separate from the element. They say the atom is the smallest part of the element. It means the atom is the element, but just a small part of it. So if the element, let's say, is H, so the atom is like small letter H. So the atom is identical to the element. In fact, the atom gives identity to the element, while the element is like the bigger version of the atom, and the atom is the smaller version of the element. So as you can see, based on the explanation I've given right now, the numbers of proton actually stands as the serial numbers of the elements in the periodic table. So if an element is number 1 in the periodic table, it means the element has 1 proton, which balances 1 electron. If an element is number 20 in the periodic table, like calcium, it's showing that the element has 20 protons, which the number of protons always equal the number of electrons, is the same that it also have 20 electrons. If an element is number 21, like scandium, we say the element has 21 protons and equally has 21 electrons. So the number of protons is equal to the serial numbers of elements in the periodic table. And what do we call this serial number in chemistry? We call it atomic number. So atomic number is the number of protons in the nucleus of an atom, and the atomic number is the serial number, and the serial number is the number of protons. So the number of protons is equal to the atomic number and is equal to the serial number of the elements in the periodic table. So the serial number is the number of protons, and the number of protons is the atomic number. So if I pose a question to you and I said, why is sodium number 11 in the periodic table? You say, well, sodium is number 11 in the periodic table because sodium has 11 protons and 11 electrons, and the number of protons equals to the serial number of the elements in the periodic table. So as big as this structure is, the weight or the mass is actually in the nucleus. Now the electron is totally weightless, which is negligible compared to the mass of the proton and the neutron. Now we've said that the atomic number is simply the number of what? Protons. So the atomic number is equal to the number of protons, which is the same thing as the serial number of these elements in the periodic table. Now the mass number, in the other hand, that is the weight of the atom, is actually the mass of the proton plus the mass of the neutron. So whenever you're asked to calculate the mass number of an atom, always add the proton to the neutron. And where do we find proton and neutron in the atom? The proton and the neutron are found inside the nucleus. As small as the nucleus is, it is actually centering the mass of the entire atom. So the weight of the atom is situated in the nucleus, and the nucleus consists of what? The proton and the neutron. So the mass number is equal to the sum of the number of the protons plus the sum of the number of the neutrons in the atom. Okay, sometimes you can be asked a question like this: calculate the mass number of an element which has 11 electrons and 12 neutrons. Now if you look at the question very well, the number, the data that was given to us is that we have electrons. They say it has 11 electrons and then it has 12 neutrons. These are the data given to us from the question, and we know that the mass number is equal to the numbers of proton plus the number of neutron. But in this case, the numbers of electrons are given to us because they want to test our intelligence. We should understand that the number of proton is always equal to the number of electron for a neutral atom. So the number of electron here stands for the number of proton. So as simple as it may look, mass number is simply equal to the number of proton, which is the number of electron, plus the number of neutron, which is 12. So 11 plus 12 is 23. So the mass of this element is 23 grams.